of your salary.
For how long? Do you know? First year, 15% for the first year, which is pretty common. I mean, that sounds like a pretty good deal, unless it's some kind of scam.
90 hours, it's 90 hours a week.
90 hours a week?
Yeah.
For how many weeks?
It's a 9-week course.
90
I'm doing it after this.
90 hours a week? What?
It's like 12 hours a day. It's just they just like steamroll you through Ruby on Rails.
For 9 weeks?
HTML, CSS.
Well, that sounds pretty insane, but on the other hand, you can't beat the price. Well, anyway, 90 hours a week. What? All right, they didn't ask me.
They say they have a 93% job placement after the program, and on top of that, the average pay is $80,000 to $120,000 a year.
I imagine, and I also imagine that you bush out a lot of students with that program. Anybody who's not really serious will give up.
Yeah.
Well, all right, anyway, that's not, check it out. If anybody goes to this, I'd like to hear reports of what happens, because it sounds a little bit too good to be true, but yeah.
So what kind of, in the field or industry recognition do you get for those type of,
I don't know, but well, see, there are things like boot camps you go to get like an industry cert, and then some people don't like it. Like, they used to call these guys paper MCSEs, but these guys claim they can place you at a job, and they're working with employers. That's like what Europe works. Europe works with the employers right from the start. And they say, if we train these people, will you hire them? And they say, yes. That's a program that works. That's the way to do it. And these guys have apparently done the same thing. They made a deal with the employers. You tell us what the rules are, how much to teach them. If they know that much, you'll hire them. So it can work. That's how it works, though. The stuff that goes on at this college, for example, is the old-fashioned stuff that sometimes fails, where people study, they get a cert, and there's no direct connection to an employer. Now you go out with a resume and try to get a job. That's how it generally works. And the purely vocational programs pointing right at one job work a lot better if you start from the job and work backwards. I had this argument because there was a thing that came out about 2 years ago. There's a huge California initiative to get people out of prison because the prisons are overcrowded. So Jerry Brown had some kind of system of moving them from the state prisons to the county prisons or something, and back in the workforce, basically. A bunch of people were going to come out of prison and be put in vocational training to get them rehabilitated so they can have a job. And there was money you could get, and some people around here wanted to apply for the money, and I was complaining on this grounds. I said, especially with a population from prison, it is not going to work to have like an A+ training where they get an A+ cert, and they say, there, now go out with your resume and get a job. You've got to have a real job at the end and a straight track that gets you to the job, or it's never going to work. And Europe has that, and it sounds like these guys have it too, but I'd like to hear real experiences of people doing it. One thing, 90 hours a week.
Yeah, they have blogs where they talk about like what they do. They do like a co-op programming, so they have someone who's a little more experienced work with you. So
yeah.
if you ever get stuck on a program, they'll show you how to do it.
Well, it sounds good, and I would imagine that if you already know something about programming, you're much better off.
Yeah.
I would think that trying to do this if you don't know anything about programming is probably hopeless.
Yeah, they take a lot of college dropouts and stuff. So it's really
So have you done it? Are you doing it?
Me?
Have you done it?
I emailed them. I'm most likely
Yeah.
going to do it once I finish my
Yeah.
once I finish my associates.
I would think so. I don't think you want to try to do school or anything else at the same time. I mean, that's okay. But anyway, it's definitely good to know, and it's nice that it's local. So, and Lord knows you need another app. So I was just talking to my grader right before class, and she is growing flowers, and she said, I wish I could see the bulbs under the ground. And I said, you could probably write an iPhone app that would do sonar, just like the sonar they do to look at women's babies in their womb. I mean, it's all you need to do is emit pulses of sound and then time them coming back. You could have the two. I bet you could do sonar in the ground to look at your flowers and anything else with just an iPhone app. You can do almost anything with an iPhone. It's got almost all the hardware you need to do practically anything. You just need to be clever enough and write the app. Anyway, that's an exciting thing to know about. So here's browser statistics. It used to be, about 6 months ago, there was a dead heat between the three major browsers. Now Chrome is one. Chrome is number 1, Internet Explorer number 2, Firefox number 3, Safari number 4.
How is IE number 2?
What's that?
How is IE still number 2?
Yeah.
Well, IE is quite popular. A lot of people like IE, and in fact, it's a lot better than it used to be. But a lot of people are forced to use IE by their companies. If you are a Microsoft Windows corporation, if you're a corporation, you pretty much have to use Microsoft everything, because if you don't, it makes it much harder to manage. Thousands of computers spread over many locations, and a lot of people just get used to it. But yeah, I mean, it's certainly fallen to number 2. anyway, that's fun to watch things change there, because a while ago you could write web pages for IE only. Like a year, 3 years ago, it was common. This page can only be viewed with Internet Explorer. What's wrong with you? Why would you use anything else? And that's really passed into the history. So this person made an email account named 18 at like some popular service like hotmail.com, and then thought they could sell it for money, but nobody wanted it, so they just left it alone for like 9 years. And now they list all the crazy mail and spam and everything they get, which is actually pretty interesting to read. So just thought I'd mention that. 18 and abandoned. It's kind of entertaining to find out what happens if you just get, you don't ever send any emails. What do you get? You get a lot of stuff. So Microsoft put out a patch, and the patch renders a certain amount of machines unbootable. They will not restart after the patch, and now they have a patch to patch the patch. So it says if your machine will not start, put on this patch. And I seem to be the only one saying, wait, how does that work? Your machine will not start. How do I put on this patch? But Microsoft seriously put out a patch, and those are the instructions. And I say, try again. Anyway, so, yeah. What's that? Well, no, apparently not. People said it's end of cycle of blue screens of death is what happens. And they never have come clean on exactly what the conditions that cause this are. Some other software causes it. It might be Kaspersky antivirus or something. Yeah.
What about reinstalling the OS?
Reinstalling the OS would certainly work. And restoring from a system image backup. And I would think I would use system restore. Boot from the CD, the DVD, and use system restore to go back. That's how I would do it. But, you know, I cannot think of a condition under which you would have put on this patch and now you're going to add this extra patch to remove it. That's not logical to me. Anyway, that happens every now and then. There was a big article that came out today that pointed out in Windows 8, if you go to the Metro screen, there is no way to uninstall things. And by the way, the same thing's true of the Mac. My Microsoft Office is not working very well on this Mac. You might have noticed PowerPoint keeps crashing. And uninstalling it is almost impossible. I went to the States. They do not have uninstallers on Mac software. They don't have uninstallers on Metro software. So they point out if Microsoft puts out a bad patch on the Metro Windows 8, there's going to be no way to remove it. They really ought to think about this and address it. But yeah.
I have a question about the browsers thing.
Yeah.
Is Internet Explorer bad because it's more vulnerable to XSS attacks?
It used to be. It used to be far more vulnerable and poorly written, and Microsoft improved it, just like they improved their OS. So now I don't think it's really any more vulnerable. In fact, if with all the protections in Windows 7 and Windows 8, it's really quite hard to take over, but it is a high-value target. So a lot of people shoot at it, although I think even that will change. Now, there's no particular reason for malware writers to primarily target IE. They ought to primarily target Chrome. So, I mean, but that takes time for them to change their pattern. For a long time, they would only attack IE because that's where all the money was. Now it's going to make it a little harder for the attackers, that's a good thing, I think. There's a big issue of legacy. When people die, their social media accounts are basically just abandoned, and you can't do anything. Even if your relatives go to Yahoo or Google or somebody with a death certificate, they can't let you in that account legally, not unless they can have a will that explicitly states, and I bequeath to them my Gmail account, in which case, if they didn't give you the password, I'm not sure they'll still do it. But I mean, anyway, so Google is now adding some feature in the Gmail, so you can specify what happens to your account when you die, because this is an ever-increasing problem. That people die and then someone wants to get in their social media account. So here's Bitcoin, back down, looks like it came up a little bit, back up to almost 100 again, so good luck with that. Anyway, just sort of keep an eye on it, because it's madness. Azure has been in like beta forever. Microsoft Cloud, now it's like becoming generally available officially. So that's pretty good. People tell me my Azure extra credit project in my Windows 7 class is out of date because Microsoft changed everything. That's the problem when you jump on a beta. But it is very important. Microsoft's Cloud is their competitor for Amazon EC2, Elastic Cloud Computing. And like I say, most big companies have to use Microsoft everything. Only small companies and very high-tech cutting-edge companies use Unix and Linux instead. Most huge corporations use Microsoft everything, and they want to put Microsoft everything in the cloud, and they want to put it in the Microsoft cloud. So, because then it will work fine with your Hyper-V and your PowerShell and everything you're using to control everything the Microsoft way. So this is really important for big companies. All right, and I just thought I'd mention, there's been this big bombing in Boston, and one thing that the president said and a lot of other people said is, don't fly off the handle with rumors. Like within an hour of the bombing, there was one person in a hospital, and the cops showed up to interview that person. which the FBI's been interviewing everybody to get evidence, and immediately the press reported they're a suspect. They're probably the bomber because they were seen running away or something. And this happened before. There was a previous bombing, and this guy named Richard Jewell was a cop, or he was a security guard that found like the trash can with the bomb in it, and told the cops, and they fingered him as the bomber. And he spent like years having to prove that he wasn't the bomber, and he was totally innocent. So that's why I mentioned that. This is a common mistake when something like this happens: is you finger somebody and it hits the press, and everybody's sure they're guilty based on nothing. So you got to really wait until they have real evidence before you freak out and blame somebody. Like some idiot already said you should kill all the Muslims, which is a terrible thing to do anyway, and they have no evidence of a Muslim doing it. What is this all about? This is a Fox News guy. You expect it out of those guys. But, you know, this is one common overreaction. So I guess I ought to give you folks a quiz. You got a quiz on Chapter 9. All right. If you have 4 500 gig drives and you want to store 1,500 gigs of data, what kind of grade will do that? Grade 5. That's why people like it. Grade 5 means you waste very little space on extra copies. All right. So what will allow your server to keep running even if the power goes out for a long time? A generator. You got to have a real power supply. Okay. UPS will not do it. Yeah.
I put intermediate, like I put the backup system in generator.
Yeah, you'd have UPS for the first half hour, and then that's just long enough to start your generator.
Okay.
Yeah, but generator is the only thing that keeps you going for any long amount of time. And that's why, actually, I was reading about some recent outage. I think it was a hurricane or something. The problem is it went on for so long that they ran out of fuel. And the roads were blocked, so they couldn't drive in more fuel. So there's a limit to how long you can get with the generator, too. But the generator usually has enough power for a couple days. All right, so if you make a backup on Friday and differential backups every other day, how many backups are you going to need to reconstruct the state of the system on Tuesday? 2. A differential always takes the difference to the full backup. So you need to play the full backup and the tape for Tuesday. The tape for Monday is not needed. If it was incremental, you'd need Friday, Monday, and Tuesday. But differential, you only need 2 tapes to reconstruct any condition. Okay? All right, so if you have an RPO of 24 hours on a backup system and something fails on noon of Wednesday, what are you going to have? That's right. You can eventually recover all the data up to a state within the last 24 hours, which would mean noon Tuesday, or realistically, probably later. Probably like 5 p.m. Tuesday is what you'd get. But anyway, that's what the promise is we can restore your data so you don't have to do more than 24 hours of work over. But whatever you did in the last 24 hours might be lost. That's what the RPO is, Recovery Point Objective. So that's what happens. You might have to do 24 hours, up to 24 hours of work over.
And in fact, into that time, and the rest of the spaces to save all
What's
the
that?
machinery, everything, all the data, the
Yeah.
networks, all the applications, everything is ready.
Well, typically, no, in a backup, you only talk about the data, typically. It's not, a backup is assuming it was just like a hard drive that failed. Not with all the equipment and everything, like a fire. That's another issue. Then you need something like a hot site or a warm site to go to. But if a drive fails, you're just losing the data. You're not losing the switches and hardware and stuff. Of course, that used to happen back in the really old days. Hard drives were things the size of a phone booth, and when they failed, they would kick out a wall and other equipment and stuff, but now they're not that way. So, all right, if your server door is secured in a fail-safe manner, what happens when the power fails? What's that? It stays locked. And it could trap somebody inside. That's fail-safe. Fail-open is the alternative. Yeah. Yeah, that's the problem. That's not what a normal person would call safe. Not safe for the people, safe for the room. Because it's super important to you that nobody goes through that door unless you can prove they're authorized. And you'll just lock the door otherwise, so you're going to have to hopefully have some other backup plan for people to get trapped in there when the power fails. Well, let's start into cryptography then. All right, good. It's going to work. So there's a few fundamental concepts here that many of you already know, like integrity, right? Integrity, it means that the data has not been modified. It hasn't been damaged by a mistake. It hasn't been modified by an unauthorized person or lost. And so in order to measure the integrity of a data, you typically use a hash function. You have the original data, then you calculate an MD5 hash, and then you can just examine the hash and make sure if the hash hasn't changed, then presumably none of the data has changed. As we mentioned before, MD5 is not a very good routine for this anymore because it's possible to forge MD5 hashes, but SHA is better. And HMAC is another one yet, where you combine encryption and hashing. But anyway, the point of all these is to assure integrity of a file or any other assemblage of data, like an image of a hard disk. You calculate the hash, you take whatever copy you have, and if the hash matches, then you trust that the whole thing is identical. Confidentiality ensures that only authorized users can view data, so other people aren't seeing what they shouldn't see, and this is generally provided by encryption. So you encrypt data and you make sure that only authorized users have the key, and then as long as there's no weakness in your encryption procedure, you have reasonable confidence that nobody is getting in there except the holder of the key. So there's two parts to this. There's an algorithm and a key. The algorithm is the mathematical process of encrypting and decrypting, and the key is this secret number, which is long and random, sort of like a password. In fact, a password is a kind of cryptographic key, and that is what protects you. There are two kinds of encryption, symmetric and asymmetric. Symmetric encryption is the classic type that's been around for centuries, where you have what I just described. I encrypt something with a secret key, like a password, then I tell somebody else the password, and because they have the password, they can open it. Nobody else can open it unless they have the password. So I have a key distribution problem. How am I going to get the key to the trusted person? I have to have some trusted channel to do that. And then, why didn't I just send my message down the trusted channel? So it is a somewhat limited use, symmetric cryptography, but it's all the whole world had until about 1979, except for the NSA that had asymmetric earlier, but it was independently reinvented by mathematicians on the outside and came out in about 79. So asymmetric encryption is magic. You send a secret message through an insecure channel without ever sending any secrets. So you make a public key and publish it to the whole world. There's a private key you never tell anybody, and now anybody that wants to can send you a secret message by encrypting it with your public key and sending it down an insecure channel because you're the only one on earth that can read it. It's one way. I put out the public key, now everyone can talk to me. If anybody wants an answer, they have to create a public-private key pair and put up their public key, and I have to use their public key to talk to them. So you can now attract secrets to you. That's all public key encryption lets you do. But you don't need ever to exchange a secret key, so you don't need any secure channel at all. You can use totally insecure media like the internet to do all of it, which is how we can now do online shopping. I can just go to Amazon, put in a credit card number, buy something, and I have high confidence that nobody's stealing my credit card number, even though I sent it down a completely insecure channel. It's very nice. So authentication is necessary because you have to know who you're dealing with. So if you're going to let somebody in, you have to have some measurement of who they are. Remember, there's identification and authentication. Identification is where you claim to be somebody, like a username. Authentication is where you put in something like a password to prove that you really are that person. A non-repudiation is another important cryptographic concept. You have to do something, and you have to not be able to deny that you did it later. Otherwise, we can't make business deals over the internet. I want to make a deal. I'm going to loan you some money. You're going to promise that if you don't make your payments, I'm going to take the car back. So I can't have you a year from now saying, I didn't really sign that. That was someone else. You cannot deny that you signed it, and I'm allowed to impound your car. So that's non-repudiation. You need this ability, and that you get with a digital signature. A digital signature uses public key encryption to create a digital signature of a message which proves that you signed it and nobody else signed it. That's because it uses a hash of the message and then encrypts it with your private key. Anybody can open it with your public key. They'll get a hash, then they can calculate a hash of the message, which is not secret, and they can verify that you signed it and that it is intact and has not been altered. So I can make a loan agreement where I borrow money and the bank will take my car if I don't pay up. I can put it in a public repository where anybody can see the loan agreement because those things are not usually secret. I got this much money and I promise to return the car if they don't pay. And then I have a signature at the bottom. Anybody takes my public key, the signature creates a hash value, it matches the message, and that proves that the message was not altered and it's the one I signed, so now I'm legally bound by it. And since the Digital Millennium Copyright Act, this is in law as strong as a real pen and paper signature. It's a way to sign a contract that will count. Yeah?
Quick question, like those signatures and stuff, say the hacker was able to get the hand on your signature hash, they could just take it.
If they could get your private key, they could forge things in your name, yes. And that is not impossible. They could put a Trojan on your machine and steal the private key off your machine, or use a keylogger or something. So, but of course, it's not impossible to forge your pen and paper signature either. So nothing's ever perfect. But this is considered as good as a pen and paper signature, and that's enough to hold up in court. And so it'll hold up, And if you want to go to court and say, I didn't sign it, a hacker stole my data, you're going to have to prove that that happened. Just to some extent. So it'll be up to your lawyers to fight in that case. But it is considered good enough to carry on business, where most of the time people will accept that they've signed the thing and they really owe the money. So I got a few eye clickers about that stuff. Come grab one if you need one. Microsoft wants to make sure that people get their update files intact. What security feature are they seeking? All right, they're looking for integrity here. They want to make sure that the files have not been altered by someone, because that would be an obvious way to poison machines, would be to put out a bad update. So Microsoft makes everybody go right to their server to get their updates. That way they control the distribution channel, which is, by the way, not stupid, because Ubuntu tried it the other way. Ubuntu distributed their files through an informal network of volunteers, and one of them did get hacked, and they put poison updates on the Ubuntu. So that could totally happen. So Microsoft doesn't want people getting their updates from some other server that's not under their control. So they pay for powerful servers, and the whole world goes to Windows Update all at the same time, and the bloody thing crashes a lot because that's a lot of load. But Microsoft would rather go to the expense of trying to beef up the Windows Update system so it can handle the whole world getting their updates all at once than to use a distributed network where other people control it. Facebook wants to know who people are. What are they trying to get? Facebook is often highly criticized. They do not want you to use a fake name. They want to know really who everybody is. All right, they want authentication. They want to know who people are. They called this the NIM Wars when they started banning fake names. It was Google Plus, really. Google Plus banned fake names. They want to know who everybody really is. Yeah?
What's confidentiality again?
Confidentiality is making sure that only authorized people can get to something. Now, you need authentication in order to determine who they are, and then you need to know if they're on the approved list. So there's two steps there.
Okay.
You can't have confidentiality without authentication, but it's different. Well, they could possibly be seeking that, but I don't think Facebook really cares about that. They're not really too concerned about you denying what you said. They'll even let you delete posts and stuff. They're mainly concerned with targeting ads. That's their big issue. And they want to know who you really are so they can tell if really what age you are and what town you live in, because it all makes the ads target better. If they let people lie about who they are. Of course, what they'll tell you is they're afraid it increases the trolling. If people put their real name on something, hopefully they won't be as irresponsible as saying rotten things online. And that might be true, too. But their main issue is targeting ads. So a long series of random bits. What's that? All right. Yeah, that's kind of what I thought. I'm not going to be able to grade this one. Now, I thought the best answer is key. The key is supposed to be random, but the hash is also supposed to appear to be random. So I don't think I'll grade it. They're both, it's not a very intelligent question. By the way, anything encrypted is supposed to look random too. These are desirable properties. They don't talk about it in this course, but in mathematical course, the encrypted message should have no pattern at all. It should look completely random. So, all right, which one of these gives you confidentiality? Encryption, that's what encryption does. Encryption is what gives you confidentiality. Encryption means a message is scrambled and only the authorized users can descramble it. And it could be public or private. That's the point. The whole point of encryption. They used to call it scrambling long before they had mathematical encryption. Back in like World War I or around the old radios, they'd have these scramblers that just change channels frequently, which is what Bluetooth does, to just mess up the signal so the only people that had the descrambler could share it. And that's all encryption is. You're trying to create this mesh that only authorized users can descramble. So no key. Which one of you uses no key? Or more. All right. And that's hashing. A hash is like also called a thumbprint of a file. You calculate the hash, you calculate it again, there's no key. But encryption, both kinds of encryption use a key. That's how you specify who the authorized users are, people who have the appropriate key. But hashing, it does not create confidentiality and does not use a key. It just creates integrity. You could, if you wanted to know if a copy of the file was accurate, you could compare every bit from the start to the end of the file. That would do it. The hashing just makes that easier. You can compare just a short hash value to have a high degree of confidence that the file hasn't changed. All right, so that's integrity with hashing. MD5 is the most commonly used hash. It's very fast to calculate. It has a short output, only 128 bits, written down in hexadecimal. It's pretty easy to read. And people use this all the time for downloads to see if disk files are okay, forensics and everything else. The problem is there are collisions. Collisions are one of the major problems hashing functions can have. A collision means you find two different files that hash to the same value. Now, in principle, they must exist, because if the hash value is only 128 bits and my input file is like a megabyte, so it's 8 million bits. There's a lot more combinations of 8 million bits than there are of 128 bits. So it is mathematically necessary that there are many 1 megabyte files that will hash to the same value. But a properly designed hash function will have the statistics arranged so that you can't find them. So even if you start hashing now and get the fastest computer and keep going forever, you'll never calculate enough hash functions to find any two that collide. That's what you want. And MD5 fails that test. There are known collisions. Yeah?
You said it's the most possible to forge it?
It is. And in your homework, you do that. There's to make two files. You get two files that are different, and they have the same hash value, and you play with them. So it was years ago this was developed. It's just not long enough. 128 bits is not long enough. And MD5 is therefore not perfect as a hash function. People continue to use it anyway, just sort of as a matter of tradition, but they really shouldn't be using it anymore. It'd be a lot better to use SHA. That's why the US government never approved MD5 for any purpose. It was around before the National Institute of Standards started defining standards, and they never approved MD5. What they've created was the secure hash algorithm. You can tell these things are defined by the government. Advanced Encryption Protocol and Secure Hash Algorithm are not what the designers named these. Those are awards. A bunch of hash techniques were developed by mathematicians, and then they competed to be the one that would be declared the secure hash algorithm for years. So that's the one got the stamp of approval from the government, and it has no collisions. There was a SHA-0 one nobody used, but SHA-1 has no collisions. So if you calculate the SHA-1 hash of a file, you have a really high degree of confidence that that file is intact. It matches whatever file had the previous SHA-1 that has the same value. However, there was an attack on SHA-1 that worried people. SHA-1 has rounds of calculation, and they weakened SHA-1, so it did something like 12 rounds instead of 20 rounds or something, so an incomplete, weaker version of SHA-1 was found to have collisions. And the number of collisions it found were more than there should have been, so people said the mathematics of SHA-1 are not that good, and they're afraid that pretty soon real collisions will be found, so the government decided to move on to SHA-2, because theoretically it takes 2 to the 80 calculations to find a collision, but they found an attack that only takes 2 to the 52 calculations, and that's not good. That's a whole lot less. That means it's not as secure as it should be. It is, in fact, secure enough for normal use, but it may not be that way much longer. Yeah? Collision is 2 different files that hash to the same value, and that should never happen. You should never be able to find those files. They have to exist, but they should be so rare that no matter how much you hunt for them, you can never find them. That's the goal of making a good hash function. So SHA-2 was approved years ago by the National Institute of Standards. They had a competition, again, where mathematicians developed a new bunch of hash functions, and they spent several years evaluating them, comparing them, and chose the best, and named it SHA-2. And SHA-2 is much longer. Making the output longer is one way to make it much harder to find collisions. So SHA-2 has 224-bit up to 512-bit lengths, which are all longer, and there are no known collisions in SHA-2 either, of course. It is mathematically superior to SHA-1. But it is somewhat related to the mathematics of SHA-1. And a lot of people were, in fact, nervous that SHA-2 would fall also, so they just last year finally completed a several-year process of choosing and approving SHA-3, which has 512 bits and other lengths, and is considered even stronger. Bruce Schneier, probably the most influential cryptographer in the world, has said he thinks SHA-3 is a waste of time. It's not worth it. SHA-2 is fine. People made SHA-2 because when they found a problem in SHA-1, they freaked, and they thought the same problem would affect SHA-2, but in fact that didn't happen. So he said, you're probably fine to just use SHA-2, but SHA-3 has now been approved and it exists. You will not find anybody using it yet. It isn't even in Hashcalc. It's not in any programs yet. It's brand new. So I did give you a homework project and the extra credit where you can calculate it. You have to go through a bit of effort to actually get a copy of the code from one of the designers and run it in Linux to run SHA-3. SHA-3 is basically just a mathematical curiosity at this point. But if somebody cracks SHA-2, we have SHA-3. We could go to that. Of course, in the real world, everybody's still using MD5. And this is what usually happens. You have the mathematicians create this beautiful stuff, and you just don't use it. Like a bunch of people just don't use HTTPS at all. They just use plain text. Great. Thanks a lot. You know, we have all this encryption, and you just don't even use it. This is irritating. They're just using FTP. Why are people hacking me? Anyway, all right. So then HMAC is a way to have more security and commonly used by financial transactions. You hash the message, and then you encrypt it with a shared private key, which might sound kind of foolish, but it is commonly used for financial transactions. It gives you integrity and authenticity. You know who that it had to come from your trusted source. It couldn't have come from someone else because only the holder of the private key could have sent it to me. So this is how people move financial transactions from bank to bank. And then, so the HMAC then has a different hash function attached, and one common kind is HMAC, MD5, and there's HMAC SHA. And in this case, MD5 is probably fine, because adding encryption to it means that you probably don't have to worry about those collisions, I would think. But in principle, HMAC SHA would be better than HMAC MD5. But both of them are probably fine. Nobody's going to get in there without having hacked and stolen the shared secret. And if they're going to steal your secret keys, then no encryption is going to save you. Then you're toast, right? And they are doing that right and left. All I have to do is get a Trojan on a machine and steal the contents of RAM and the files off the hard drive, and you can get the keys. That's a fundamental weakness in the whole system. Yeah?
So, HMAC is actually encrypted?
An encrypted hash, yeah, both. You calculate the hash, and then you encrypt it with a shared secret, so you know it had to come from the trusted person that had the secret. Yeah. All right. So there are different programs out there to hash files. Hashcalc in Windows is the one we use in some of the projects here. That's just a freeware that works. Filealyzer is one I used before, but Filealyzer actually had some wrong hash calculations in it at one time. Irritated me. MD5 Sum is a command line program you can download for Windows or Linux. That's fine. Lots of ways to do it. So here's Hashcalc. Windows machine, Filealyzer, just another one, which is fine. You can hash, so I use Hashcalc on the PC. On the Mac, I just use command line commands, and the OpenSSL will do it. OpenSSL MD5, OpenSSL SHA-1, OpenSSL SHA-256, 384, 512. They're all just right there at the command line on your Mac. Or in Linux, if you have the OpenSSL package, and most versions of Linux come with that. If not, you can just add it easily. The only thing you don't get is SHA-3, because it's too new, and there's actually no real commercial interest in making it readily available, since SHA-2 and SHA-1 seem to be holding up just fine. But there's SHA-3. You can do it in Python if you download, you set up Git and you get a GitHub from one of the developers that developed SHA-3, and you can calculate it. So there's the SHA-3 256 of, I think, an empty string. Pretty long and nasty, and hopefully that thing has no collisions. So you can try that if you like in Project 12X. So hashing gives you integrity. You got a message here saying something, the price, it has a hash. Then you send this. If somebody modifies it, then the hash won't match. Which it does appear to be matching, and therefore I'm not getting it. This picture appears to be wrong. If they change the price, the hash will be different. This is the one that didn't get changed, so the hash matches. So there's a defect in the logic there. But anyway, if you did change the price, the hash would change. Every bit in it would change. It wouldn't. If you have two messages that are similar, the hashes are completely dissimilar. This is a fundamental process of hashing. So you change anything, the hash will change. And here, let me just show you that in the command line. It's easy enough to do. So if I kill this and make this bigger. All right. So let's do echo AAA to foo. Okay, now if I cat foo, foo contains 4 A's. So I can do open SSL MD5 of foo. And there is the MD5 hash of my file that contains 4-letter A's. Now if I add something to it, like echo B, and I put that at the end of foo, now if I look at what's in foo, foo now has 4 A's and a B. And now of course if I do OpenSSL MD5 foo, I get a different answer, and it's completely different. E58 turns to F21, and so on. 063 turns to EDA. That's the point. So if you look at the hash tells you whether the file has changed. In this case, the original file is shorter, but the original file is typically much longer. And in practice, I usually just look at the last couple of digits of the hash to get a pretty good idea, but you can compare the whole thing. Yeah?
I was going to ask about for smaller files, can the hash be the same?
No. If there's even one bit different in the file, the hash will be totally different.
I'm saying, like, okay, let's say MD5. If I make MD5 is 128 bits.
Yeah.
Let's say it's SHA.
Yeah.
256 bits. 256.
Yeah.
If I have a file that is smaller than 256 bits.
It'll still, the hash can be calculated even from an empty file. The input length does not matter. So, and you can do that one. That's a well-known. So I can echo nothing to empty, and then cat empty. There's nothing in there. It looks like you put a carriage return in, though. It's not quite things. You can make a really empty file and calculate a hash on it.
Two empty files will have different hashes.
No, if they're both empty, they'll have the same hash because they didn't change.
If you create one empty and then create another empty.
Yes, and by the way, this is a really important point. This is one I wanted to bring up to people. It's if you do, I made a file called foo right here. That file contains AAAB. Let me just do it again. I'm going to do one line. I'm going to put AAAB to foo1, and I'm going to echo AAAB to foo2. Okay, now, if I do ls minus l, oops, get rid of that extra character. Okay, foo1 and foo2 both have 5 characters. They have AAAB and then a carriage return. Now, if I calculate the hash of these 2 files, is it going to be the same or different? They have different file names, but the same content. What do you think? The same? Who thinks they're different? Right, let's try. So we'll do MD5, open SSL, MD5 of foo1, and open SSL, MD5 of foo2. They're exactly the same. The contents are all that matters. The file name does not matter. This is the difference between data and metadata. There's a data stream in a file, which is the contents, and there's metadata, which is the file name and the last access date and the permissions of who's allowed to modify it and all that jazz. And that is added by the operating system when it stores the file, but that's not part of the file. It's like what's outside an envelope and what's inside the envelope. The contents of the file is just those letters. The outside stuff like drive it's on and all that has nothing to do with it. That's an important concept.
This is true in the Windows operating system as well?
Sure, it's the same anywhere, yeah. The metadata is different than the data, and the hash only hashes the contents of the file. This is a common problem with Microsoft products. There are Microsoft encryption products that encrypt the contents of files, but they often do not encrypt the file names. So if you have a secret, don't put it in a file name. Anyway, because the file name is stored separately. Anyway, so that's HMAC. So now in principle, see what they're worried about here is that someone will change this price and they'll change the hash. And so when you get it, the altered price will match the altered hash. So to avoid that, you have this secret shared key to prevent an attacker doing that. That's why the financial system likes to use HMAC, which includes both encryption and hashing. Now it's impossible for someone to alter the financial terms in transit and have it still pass the authentication at the end. All right, so the only way to avoid this kind of man-in-the-middle attack is either a trusted third party, which can verify that the key has not been altered, or a shared secret, which you somehow exchange beforehand, which enables you to verify that the key was created by the authorized user. So, and that's a fundamental issue. We'll come back again and again. You end up having to trust somebody for encryption. All right, so RIPEMD is another hash algorithm that's sitting out there. It's around. It's like as good as considered like SHA-1. It's not that commonly used. And there's other ones. Now, Landman password hashes are really important in the world of security. In the old days, you would store passwords as plain text files. Then people figured out that's a terrible idea because someone can hack and steal that file and they have your password. So you cache them. And then when the user logs in, you hash the user input and see if the hash matches. And that way you never have to store the plain text password anywhere. You can recognize the valid password when it comes in without storing it. Unfortunately, Microsoft used these Landman hashes, which are too weak, too easily cracked. And so you should disable them. All versions of Windows after XP finally quit using them. And you can disable them here in group policy. There's a thing here called Do Not Store LAN Manager Hash Values on Next Password Change. If you enable that and then change your password, Windows XP will no longer use that terrible crackable hash system. And so your hashes are more secure. These days, people can break them anyway. But here's what's wrong with Landman. If you have a long password like this, Landman will break it into 2 7-letter fields. So the first 7 letters will go here, and the next 7 letters will go in a second field, changes all the lowercase to uppercase, and then hashes them separately using good old DES, which we talked about before. I think DES is a well-known broken cryptographic system. It's not strong enough. So it is pretty miserable stuff. And it turns out, in the hacking class, if you do this, you use a product called OffCrack. You can just go crack these things in like 10 minutes. You can just have plain text passwords off a Windows XP machine. It is a sin and a shame. So Microsoft invented a better system called NTLM. This has been around for a long time, but unfortunately they maintained both systems for many versions of Windows, so you'd have backward compatibility in case you have MS-DOS machines on your network. And now they finally gave up on that in Windows Vista, and they no longer have backward compatibility with that old system. They use NTLM. NTLM uses MD4, which was before MD5, so it's still pretty old, but at least it doesn't shorten your password down to 7 letters and change all the lowercase to uppercase, which is just rude. So if you have a long password that's got random characters in it that's, hard to crack, the hash is also reasonably hard to crack. Of course, if you use a password in a dictionary, anybody can get in pretty fast anyway by trying all the dictionary, but you can't have everything. At least now, if you do choose to have a 20-character password full of long, complicated random numbers, Microsoft doesn't undo all that complexity and store some junk that's easy to crack. So it's pretty good. And so and you can control your NTLM here in, again, in network local security settings. You can control which NTLM versions will be used, but the version used for password hashes is always the same and has never changed since 1993. The only thing you're changing here is the version used for network authentication over the wire. When you log into a Windows machine and then you access a password-protected share, it has to pass authentication up to the share server to tell if you're allowed in, and that involves passing a hash of your password over the wire. And that's done with NTLM now. It used to be done with Landman, so you didn't even have to hack into a machine. You could just sniff the network and get passwords by cracking the hashes of what was flying around the network, which is pretty rude. And here's how NTLM2 authentication works over the wire. It actually uses HMAC MD5, which is pretty nice. So it's reasonably strong, the stuff that's used over the wire now. All right, and here's NTLM v2 and Windows versions again. It shows different versions. If you use Windows 2000 and Windows XP, it will send LM responses over the wire, Landman hashes. So it's basically sending your password in a reversible form over the network. If you use Windows Server 2003 and later products, then it sends the more secure NTLM or NTLM v2 hashes over the wire, which are harder to crack, unless your password itself is simple, but then nothing can much save you. So I got a few iClickers. Yeah, go ahead. Because this is a really common issue. This is the downgrade attack issue. If you use the later products, like Windows Server 2008, it only sends NTLM v2, which means you will not be able to communicate with, say, a Windows 2000 file server, because it doesn't have the ability to speak NTLM v2. So if you use the most modern secure algorithm, you cannot also support coexistence with old stuff. This is a very common issue. This is why one common way to break into a server is a downgrade attack. Contact the server will offer you 10 encryption routines, lie to it and say, I'm sorry, I'm Windows 95. I can't not take any of those complicated routines. You've got to use 40-bit encryption. And that'll be the weakest kind of encryption used in that session. So that's the point. This one will have either LM and NTLM are sent by XP, so it can easily communicate with DOS or anything up to that time. This one is LM only. And these one are NTLM v2 only. So those products can only communicate all at the same level. So if you mix when you make a domain controller, you'll have one critical decision when you first run DC Promo, which is that do you want a native domain or do you want a mixed domain? And a native domain means if you're setting up Server 2012 domain, all the other domain controllers have to be Server 2012 or greater. And then it will be the most secure. A mixed domain means I'm going to also have old things like Server 2000 domain controllers on my network, and then it will do this. It will support all the old insecure protocols, so it can talk to older controllers. So mixing old stuff with new stuff is a very unwise practice, but corporations do it all the time because they have stuff that has been sitting there for 10 years that's working, and they don't want to touch it, and they want to buy new stuff and add it, and then have it be compatible with all the old stuff. And you can do that, but at the cost of security. Then your security is going to be 10 years out of date. You're going to have traffic flying around in your network using a protocol that has been upgraded. Good. All right. So we'll try a few of these. Which of these is the most secure? All right. Obviously, the last one is best. They wouldn't have bothered making it if it wasn't better. This is chronological. If they weren't making it better, unless they make a terrible mistake, which sometimes happens, usually the later thing is better. Which one of these is a defect in a hashing system? All right, collisions are something you don't want. Everyone knows that. Good. Okay. So which one is so new we are not using it yet? Oh, and that's SHA-3, obviously. Yep, everyone got that. SHA-3 is the new one that is not included in any commercial products yet, and probably won't be for a while because there's no real need for it right away. Which technique reduces or resists man-in-the-middle attacks? All right, and that is HMAC. HMAC has a shared secret, so if someone in the middle interferes with your communication, they cannot forge acceptable communication because they don't have the shared secret. All the rest of these do not protect you from a man-in-the-middle attack. And the last one is Windows 7 login passwords. How are they stored? Right, they are stored as NTLM hashes, which, by the way, is MD4. Anyway, but they call it New Technology LAN Manager to replace the old Technology LAN Manager.